Namaste, welcome back to another video. In the previous video, we studied about pollination and types. In this video, we will study about how that pollination is brought about. That pollination is brought about by some agents and we call them agents of pollination. So all those agents of pollination have been categorized into two. They are abiotic agents and biotic agents. The abiotic agents, where already we know A stands for no, and biotic stands for life. So these are the one who do not have life, and that they are the one who will carry pollen grains from one plant to another plant, or from one flower to another flower. In the case of biotic agents, there are animals who will carry the pollen grains from one plant to another plant, or from one flower to another flower, right? So out of these two types of agents, right, the majority of plants will use biotic agents, whereas only a small portion of plants will use abiotic agents. And among them, the most common is this wind pollination. So this is the most common among, and that too it is very common among grasses and very common among grasses. So out of the wind and water abiotic agents, it is the wind that is very common when you compare with water, and in case of grasses, the wind pollination is a very common type. Right, now we need to keep a point in the mind. So in the wind and water pollination, the pollen grains coming in contact with the stigma is a chance factor, right? As the pollen grains are released into the air, right, or into the water, whether they reach the destination is a question mark. So that is right, that is a chance factor. And because of this, it has to produce a lot of pollen grains. So if it produces a very less number of pollen grains, then there is a less chance of those pollen grains reaching the destination, that is another flower present. So that is another flower, right? So because of this uncertainties, and pollen loss, the flowers produce an enormous amount of pollen grains. So that is how right, in the case of wind and water pollinating plants, so a lot of pollen grains have to be produced, so to compensate the loss. Now out of these two, we will see the abiotic agents, that is a wind pollination. So among this wind pollination, if that pollination takes place by wind, then it is called anemophily. It's called anemophily. So where from the Greek, the word has been taken from Greek anemos, which means wind. And here these plants pollinated by wind, the plants pollinated by wind are called anemophilous plants. They are called anemophilous plants, and these anemophilous plants have some characters. They produce some the special character, the special characters seen in the case of flowers. So that's what the characters of wind pollinated plants. So there is a special adaptation seen in the case of those flowers, because they will be pollinated by the wind. So let's see those characters of the flowers. Here, so characters of wind pollinated plants, especially in case here I am talking, or I will mention here wind pollinated flowers. Characters of wind pollinated flowers here. So now the pollen grains are small in size, because they have to be carried by wind, their size has to be very small. If they are larger, they cannot be carried by the wind so easily. Okay, and they should be very light. Okay, and they should be smooth, and they should be definitely non-sticky. If they are sticky, then they will get attached to some other substrates and so and will not be able to move freely. And they should be powdery, and mostly in all those they are powdery for easy dispersal by wind currents. So that's one character you will see in the flowers pollinated by wind. And another one, where flowers do not produce scent or nectar, because there is no need of attracting any biotic agent in the case here. They are not attracting biotic agent, so that the wind cannot smell or cannot see the color. There is no need to produce scent or nectar. Then the calyx and corolla so are highly reduced or maybe absent in case of some species. And then they often possess well exposed stamens. The stamens will be well exposed into the air, so that the pollen grains can be easily dispersed by the wind currents. And again, the anthers have versatile attachment. So versatile attachment, which means so this is an anther. So the anther is attached to filament. So there are half a dozen types of attachment of filament with the anther, and one type is this versatile type of attachment. So this is anther. So this versatile attachment, so the filament is attached to this anther at the middle, so that the anther has a free movement. So the anther can move freely from the center point here. Because of that, it can easily release the pollen grains into air. So that's what the anthers have, versatile attachment, so that they can easily swing and liberate pollen grains. Then they often have single ovule in each ovary, and numerous flowers will be obviously packed. So most of these wind pollinated plants will be producing something called inflorescences. Let's see the example of that corn cob tassel. So we may see in case of this, this is you will see in case of maize. And in case of maize, whenever you see so you will find a lot of a long silky hair like structures you will find here, and these are all actually the styles. At the base of this there is a ovary, and on the tip you will find the stigma here. So you will find, so all these, this is a stigma here. At the base of this you will find ovary. So this is a red corn cob, and so these styles are so long that they are adapted to trap wind-borne pollen grains. So here the styles are long, and are, of course, that is a adaptation here. So that is, they are adapted to trap wind-borne pollen. So the pollen grains will be, of course, in case of wind pollination, they are released into the wind, and the wind will be carrying these pollen grains, and to pick those pollen grains present in the wind, these styles have to be very long with a sticky stigma at their tips. That's what we see in the case of corn cob as an example for this wind pollinating plants here. The next one, and another point, that flowers are borne on long stems. The flowers are borne on long stems. So, and well raised. Means, so the long stems will help them to be exposed into the air. Okay, so that's what well raised here. The flowers are born on, okay, long stems and well raised. This you will see in case of sugarcane. In sugar canes you will find such type of inflorescences. And then right, the and another point, pollen grains are produced in abundance. The pollen grains are produced in, okay, abundance. Okay, so this is to compensate, okay, the loss. So this is to compensate the, okay, lost. So that's what okay, so as I mean, most of the pollen grains obviously will never, I mean, they may not reach the destination. There should be more number of pollen grains produced, so that increases the chance of the pollen grains to reach their destiny. Okay, right. So we'll see this when pollination, okay, in what plants the wind pollination is very common here. Okay, so the wind pollination is very common in, of course, sugar cane, okay, grasses, which I have already mentioned. So it is seen in the case of okay, grasses, then bamboos. So in them also the pollination, it will be by, okay, wind. And then, okay, millets, okay, and here already, which I have mentioned, okay, maize. In maize also it will be by wind pollination. Okay, then paddy, etc. In all this wind pollination, the pollination takes place by wind. So that's all about, okay, the abiotic agent wind pollination. So the next one we'll study about water pollination.